Hi, and welcome back to the class, R for Journalists. We are continuing our exploration of ggplot 2. So we've gone over a few charts, and we've looked at how to change up some of the aesthetics for some of the geoms. We're going to now go over more geom types. So we've focused a lot on bar plots, geom bar. So let's look at some other things, like we'll start with ggplot 2 again. And we'll use the data frame ages, and this time we don't have to do data equals ages because it assumes that the first variable you pass to it will be a data frame, and then we'll keep it in one line, AES, and this time we'll focus on the actress age, and the Y will be the actor, because remember we have 6 variables. And we're just going to play around with what this looks like. So this time we're going to use the geom jitter. Let's take a look what that looks like. Okay. Let me make sure I zoom in a bit for you all. Sometimes it zooms me back out. Okay, so that's interesting. It's a little tough to read, but you can see the distribution of it pretty well, depending on the Y. It's grouped by actor. So let's throw in an AES into there. Just going to repurpose my code. And at the end of this AES, I'm going to add the color equals genre. Maybe genre affects how it looks. Okay, so now it spits them out automatically, and we can see Tom Hanks likes to be in a lot of dramas. His dramas tend to be older women. Johnny Depp, fantasy, a lot of younger women. So you can kind of see that based on that if you look pretty closely. Let's try another geom. Box plot. ggplot ages. AES, and we're going to pass it, the X is going to be the actor this time, and the actor's age. So we're going to split it. Rotate it. Transpose it, I guess. Actor's age. And the geom is called box plot. Geom box plot. So let's take a look at that. Okay, so the height of the line is the max and min of the numbers and the actor's age of the distribution. So the top of the box is the top quartile. The bottom line is the bottom quartile. The line in the middle is the median age. And that floating dot, that's an outlier. So there are some other options you can pass into geom box plot, like fill, color, notch, like let's say notch equals true. And so statisticians love this type of chart. You're not going to see this too often in data viz in newsrooms, but sometimes it might justify it. Okay, so another type of geom. Let's try geom violin. It's another way to show distribution, except it's a little bit clearer than a box plot. All right, so you see the outlier is now part of this. And you can see this is where it's wider. That means there are more actresses of that age in this group for George Clooney. So the wider the diameter, the more numbers there are. It's a little bit more intuitive to follow. So we used 2 variables here. So let's talk about scaling, which is useful to transfer or rescale data with. And a way to show that is with a histogram. So ggplot data, ages. AES X equals actor age. So let's look at the distribution of how old these actors are using the geom histogram. Okay, so we can see that goes from late teens to the 60s, and mostly they're in their 30s and 40s, and sometimes mid 50s. So there are common options to pass to geom histogram. That's bin width, and that's color, that's fill. So let's change the scaling by passing a logarithmic scale. Scale log x, scale x log. Couldn't find function as scale x log. Pardon me while I Google this. It's because I forgot to add a 10. Okay, so you see that it kind of shifted a bit. So this is useful for maybe some color classification. I just wanted to show you that it's possible. Let's see, what else? We can talk about kernel density plot. That's gplot. Ages, AES. I'll split the lines up so it's easy to read. AES x equals actor's age. So let's look at, we're looking at the distribution of actors' ages. And this time, instead of using that histogram, we're going to use geom density. And we're going to make the color fill equals red. Okay. So they all hover, it's mostly within their 20s and mid-30s. So there's some options you can pass to geom density, such as fill, color, and alpha. So let me show you what that looks like. And actually, let's add another variable in there because we have actor's age only. Let's throw in the actor and see the distribution that way. And this time fill will be actor plus geom density, and we're going to give it alpha equals .3. That means transparency. So you see why we're doing this. You see how they're both kind of very similar, but we're adding a little bit another variable in there, and it looks like this. So by breaking it out, by disaggregating it a bit, you can see that George Clooney definitely has more women, acts with more women in their mid-30s. Johnny Depp, much younger women in their early 20s. And I think this Tom Hanks has a pretty good distribution. Okay, let's go to the next one, which is dot plot. ggplot ages, AES x equals, we're going to give it the actor's age this time, and y will be movie name, and we're going to give it geom point. So it's sort of like a scatter plot we did before, but this time the y is not going to be a number. It's going to be a category, which is a string of. Okay, so it's a little bit tough to see on your screen probably because it's the text is all jumbled together and it's very tiny. Hopefully it'll reflect, you can read it on your screen much better, but you can see it's in reverse alphabetical order. So it starts with working girl, witness, what's eating Gilbert Grape, and you can see the distribution of lines that way, and that's pretty nice. So speaking of lines, let's talk about line plots or fever plots. So let's start by summarizing the ages of the actresses per actor. We're going to bring in the library dplyr. A lot of fun with dplyr, right? And we're going to calculate with summary, right? Average age. It will be the new data frame, and we'll start with age is data frame. Pipe it to group by actor. We're going to find the average age of the actress per actor, and we'll group by the actor first. Mutate is actually we're going to find the average age difference, right? That would be more interesting. So age diff equals actor age minus, how do you spell that? Actor age, actor's age. Yeah. Okay, so we start out with a new column that way. I'll just show you. We can do step by step to show you what that looks like. It didn't look like that for some reason. Oh, that's fine. So right now we have a new data frame, and we have added a new column called age diff. And let's add another step, which is summarize. And that's average age diff equals mean of age diff column. So now I've got it down to 7 actors and the average age difference. So I can just show that as a table, sure, or I can kind of show it as a line graph. So ggplot average age, AES will be, X will be the actor, Y will be the average age diff, and I'm going to group it by 1, because that's kind of what you have to do with this type of summary, plus geom line. And that's what it looks like. Denzel, Harrison Ford has the biggest age difference, and Richard Gere as well. And Tom Hanks, very minimal age difference, average age difference. Okay, does this chart really succeed? No, I mean, because it's too categorical, and it doesn't make sense to like connect them like in a stock market prices, you know. But that's the point of kind of iterating through this. You just change it up by getting rid of this line and swap it out with like geom bar, and suddenly, you know, everything is nice again. So geom bar. Oh, and when you have this type of data frame, which is the Y is no longer is tied to an actual number in here, then in geom bar you have to pass it stat equals identity. It's just one of these quirks for geom bar. So yeah, this chart makes way more sense. But let's go back to it, because I need to show you one more thing. Geom line, and then you can layer on different visualizations. So geom line plus geom point. Okay, so you see the difference? Geom line looks like this. So geom line plus geom point looks like that. So it kind of emphasizes where the number is, and that might work for your visualization. So common geom point options that you can pass are color, fill, size, if that's what you want to do to really emphasize the points. So let's do a scatter plot with a fit. So ggplot ages, AS x equals actor age, comma y equals actress age, and then geom point again. I'm going to start out with that layer first, and then geom smooth. See how that looks? Okay. And then we can also customize it by throwing in a linear regression line into it. So geom smooth is now method equals lm for linear, comma, formula is y tilde x. You don't really need to understand this. You can I just want to show you that this is possible. So I've got a linear regression line between actor's age and actor age. Just something cool. All right, got quite a few more things to go through. So let's go to grouping now. This is kind of fun, and we've kind of done this before. So let's start out with the scatter plot of ggplot ages, and AES can be x equals actor age, y equals actor's age, and this time we're going to pass it the color of the actor himself, plus, and we're going to make a scatter plot, right? So geom point. So you see what we've got here. We've thrown in 3 variables now, and we can kind of see some patterns. So we're packing more information into a chart with just a line of code. And when you're exploring data visually, this might help surface insights you wouldn't notice just by looking at the raw data. So everyone's pretty clustered in this chart, so you might not be able to see outliers like Tom Cruise, who's purple over here, and Johnny Depp on the bottom left. But everything else in the middle is just kind of muddled together. So let's go crazy and add another variable. So I'm just going to copy and paste my code. And after color, I'm going to add a genre, and I'm going to visualize that with the shape. Run that. Okay, so this is really, I don't know if you can see it, but if you have it running on your computer, you can see it much better. And so you see the genres represent all these shapes, actors are the colors, and so you got, little sci-fi squiggles here and triangles and stuff. We were able to fit 4 variables in here. We got actor age, actor's age, actor, and now genre. The problem is it does not look good. But why did we do this? I just wanted to show you that these shape options exist. You'll probably never use it. I hope you never use it. But we've got... What if we keep trying the color and the shape to one variable? So we can also change color and shape to actor. Let's just run that for fun. Okay, so it now kind of shrunk those legends together. So the colors and the shape are all the same. But what you see here, Tom Hanks. Poor Tom Hanks has been left out because there are not enough shapes out of 1, 2, 3, 4, 5, 6. So there's 6 default shapes in ggplot 2. Anything more is... They're like, why are you doing this anyway? It's confusing to the reader. And I would argue that that's the same thing with these categories of colors. Anything more than like 6, even 7 is just too much. So let's see. Okay, so instead of using shape, let's deal with size. And because we want the size of the circles to represent something numeric, what do we got? We don't need ages. We got budget. So let's put in budget. And run that. Alright. This is pretty interesting, right? So you see Tom Cruise seems to be in really big budgets. Tom Hanks is in big budgets. Johnny Depp. Younger actresses tend to be in smaller budget movies. Older actresses tend to be in bigger budget movies, I wonder. So we were able to fit 4 variables in here, and we've made it work. It kind of makes sense. So there's a lot of data being communicated to readers here, and on top of that, the legends were auto-generated. That's pretty cool. All right, let's see. Let's move on to chords, as in coordinates. So you'll see the stats in that geom bar thing I was talking about. So this is statistical information that summarizes data. That stat equals identity. In this instance, we're setting it to identity, right? Because we want the bars to represent the numbers in the Y in the AES, not the count of it. So we're going to go alter the coordinates of the chart that we got in that other horizontal one and make it. We're going to transpose it again. So let's start with ggplot data with that summarized data again. Average age, AES, X equals actor, Y equals average age diff, geom bar stat equals identity. Okay, so you remember when we did this? Pretty cool. Now all we have to do to transpose that is add chord underscore flip. Check it out. Okay. We flipped it. All right, so good job. We've gone through a lot of different chart types and geom types. And in the next section, we're going to talk about facets and small multiples. It's really great. So I'll see you then.